Hello all, I'm Gokula Krishnan from second year ECE. In this case study, we are going to see about Schottky diode. Schottky barrier diode. The Schottky diode is a semiconductor diode with a low forward voltage drop and a very fast switching action. When current flows through the diode, there is a small voltage drop across the diode terminals. A normal silicon diode has a voltage drop between 0.6 to 1.7 volts, while a Schottky diode voltage drop is approximately 0.15 to 0.45 volts. This lower voltage drop can provide high switching speed and better system efficiency. Construction. A metal semiconductor junction is formed between a metal and a semiconductor, creating a Schottky barrier. Typical metals such as molybdenum, platinum, chromium, and tungsten on the semiconductor would be typically N-type silicon. The metal side acts as anode and the N-type semiconductor acts as cathode of the diode. Schottky barrier results in both very fast switching and low forward voltage drop. Working. The electrons of the N side having low energy level than that of the metal, so electrons can't cross the junction barrier called Schottky barrier. In forward bias, the electrons of the N side gain enough energy to cross the junction barrier and plunge into the material with a very large energy. They are called hot carriers, and diode is called hot carrier diode. This is the VI characteristics of the Schottky diode. Reverse recovery time. The most important difference between the PN and Schottky diode is reverse recovery time. When the diode switches from conducting to non-conducting state, where in a PN diode, the reverse recovery time can be in order of hundreds of nanoseconds and less than hundreds ns for fast diodes. Schottky diode does not have recovery time as there is nothing to recover from. Some important points about Schottky diode. Schottky diode is a metal to semiconductor junction. Schottky diode is majority carrier device unlike to normal PN junction diode. It does not have charge storage region. There is very fast speed. Semiconductor used is N-type. Semiconductor region is lightly doped. It is operated at high frequencies from few megahertz to gigahertz range. Limitations. The most evident limitations of Schottky diodes are relatively low reverse voltage ratings from silicon metal to Schottky diodes, typically 50 voltage and below, and relatively high reverse leakage current. Some voltage designs are available. 200 volt is considered as high reverse voltage. Reverse leakage current, because it increases with temperature, leads to the thermal instability issue. This often limits the useful reverse voltage to well below the actual rating. While higher reverse voltage are achievable, they would be accompanied by high forward voltage drops compared to the other types such as Schottky diode would have no advantage. Applications of Schottky diode: voltage clamping and clipping circuits, rivet current and discharge protection, rectify high speed signal, low power TTL logic as a switching devices. Thank you.